Hello, today I'm going to go through lesson 3 on independent versus dependent probability. So I'm going to kind of skip down right to the examples and kind of go through a few here. So basically our rule is when two events are independent, we'll get into the difference of that in a minute, the probability of both events occurring is going to be the probability of your first event times the probability of your second event. It kind of works with what we've been talking about earlier. If you're saying in your head the word or between two things, you're going to add them. If you're saying in your head the word and between two things, you're going to multiply them. So let's look at the first example here. A coin is tossed and a six-sided die is rolled. We want to find the probability of landing on the head side of the coin and rolling a 3 on the dice. So I'm looking for the probability of getting a head and getting a 3 on the dice. So you're going to handle each probability separately. Probability of getting a head when you're tossing a coin is 1 out of 2. And means times. And then the probability of rolling a 3, that's one option out of 6 on your dice. And then you're going to multiply. When you multiply fractions, you can use multiply top, you multiply bottom. So 1 times 1 is 1, 2 times 6 is 12. That means you have a probability of 1 out of 12. Looking at the next one, again, this is another independent event. A card is chosen at random from a deck of 52 cards. It is then replaced, and then a second card is chosen. What is the probability of choosing a jack and then an 8? So again, handle each probability separately. A probability of a jack, there's 4 out of 52 cards that are jacks. And means times. Probability of an 8, there's 4 out of 52 cards that are 8s. And then you just multiply your probabilities together and make sure you reduce your fraction if possible. And you're done your probability. These are considered independent events because they aren't related to one another. One event doesn't affect the outcome of the other one. And you'll kind of see the difference in a minute. And I just wanted to kind of pause and compare to what we were doing yesterday. Yesterday we were talking about mutually exclusive and non-mutually exclusive events, and we were using the word or. So yesterday, for example, we would pick a card from the deck and just wonder, what's the probability it's a jack or an 8? That means yesterday's things, we were only looking at one event. This doesn't actually answer this question, it's just a little summary here. And we used the word or, which was this symbol here. And in that lesson from before, we would add our probabilities because we're using the word or. And then we would think carefully, is it mutually exclusive or non-mutually exclusive? For example, if I said I was drawing a card from a deck, what's the probability it's a heart or an ace? You would have to be careful to minus off the possibility of an ace of hearts because you counted that one twice. So you have to be careful if they can be both at the same time. You're going to have to minus that off from your total. That was yesterday's lesson. The lesson from today, now we're doing something with the word and. We're pulling a card and we're pulling another card. That means we have more than one event occurring in today's lesson. We're using the word and instead, which means we have to multiply our probabilities. And now we have to be careful to think if our events are independent or dependent. So far, we've just talked about independent events. The next few on the next page are also independent events, but let's skip down and see what does it look like if we have a dependent event. Well, actually, I want to go through one more first. 2 children in the Smith family. This is, again, an independent event. Determine the probability that if you have 2 children that both are boys. So if I wrote that out, it's the probability that you have a boy and another boy. If you're to calculate that probability, chances of having a boy when you're pregnant are 1 out of 2 possible options. You could have a boy or a girl. And means times. Because you had a boy first, it doesn't impact the chances of you having a boy the next time, so you still have a 1 out of 2 chance of having a boy the next time. So your probability, if you have 2 kids that they're both boys, is 1 out of 4, 25% chance. Now we have to be careful with the next question. When you're doing probability with independent dependent events using the word and, order is implied. So your first one is your first outcome that you're doing, and the second one is the second outcome that you're doing. So in part B, it says determine the probability that one child is a boy and the other child is a girl. You have to be careful because what this says is that your first child is a boy and your second one is a girl. We have another scenario here to give us this outcome. We could have also had the situation where our first child was a girl and the second child was a boy. Both of those scenarios would give me what I'm looking for, which is one child is a boy, one is a girl. So you have to be careful if I don't tell you that there's a first event, a second event. You might have to look at different scenarios to do it. So to solve this one, start in order. Probability of a boy is 1 out of 2. Times probability of a girl is 1 out of 2. That's my first scenario here. The word or means plus. Now I'm going to do probability of a girl, which is 1 out of 2, times probability of a boy, which is 1 out of 2. So in this case, my probability is going to equal a half when it's simplified. Okay, so those are all independent events. Let's look at an example of dependent events. So, a card is chosen at random from a standard deck of 52 cards. Without replacing it, a second card is chosen. What's the probability that the first card is a jack and the second card chosen is a 5? So we started out the same way. Probability of a jack is 4 out of 52. But now that I've pulled out that card, I selected a card, I've got my jack, I'm holding it in my hands. Now it tells me in the question we're not putting that card back in the deck. So I'm holding it in my hand. I'm reaching back in to try and get a 5. What's my chances of getting a 5? Well, now I still have 4 5s in that deck, but I only have 51 cards left to grab from because I'm already holding that jack in my hand. So this is a dependent event because this probability was altered slightly because of what happened in my first event. So when you simplify that, you should get this as your probability. So let's look at just a couple more examples of that. It kind of gives you the general rule here. If it's a dependent event, you're going to do your first probability regularly, but when you do your second probability, you have to take into account that A already occurred and it might impact it. So let's try this one here. Mr. Jones needs 2 students to help him with a science demonstration. The class has 18 boys and 12 girls, or 18 girls and 12 boys. So there's a total of 30 students in my class. 18 girls, 12 boys. He randomly chooses one student who then comes up to the room. He then chooses a second student from those still seated. What is the probability that both students chosen are girls? So I want to look at the probability. We have a girl come up and then another girl come up. So for the first probability, a girl coming up, there's 18 girls out of a total of 30 students. And means times. Now we've chosen that first girl. She's standing up at the front of the class. Now we have to choose another girl and the probability of getting another girl. So now there's only 17 girls remaining that you can choose from out of the remaining 29 students in the class because you already have one girl at the front. So that would be your answer to this one. And as a simplified fraction, you should get 51 over 145. Likewise, I'll do one last example. In a shipment of 20 computers, 3 are defective, 3 are broken. We're going to randomly select 3 computers to be tested. What is the probability that all 3 are defective? Probability that all 3 are going to be defective. So you're going to think, you're going to go into that room, grab a box. The chances that that one's going to be defective is 3 out of the total of 20 computers. And we have said that these ones that we pull, the first and second ones, are not replaced after being tested. So once I have that defective one in front of me, I'm going to go and choose another computer system. So when I go back, I already have a defective one with me. There's only 2 left that I could grab out of the remaining 19 computers still in the room. Then that one ends up being defective. So now I have 2 of those defective ones here. I'm going to go back into that room to get my other computer. There's only 1 defective one left out of a total of 18. And then you're going to get your total. Once it's simplified, that's going to be your probability. So those are all examples of dependent events where you have to be a little bit careful because whatever happens first might kind of change the probability of your second one. Let me know if you have any questions at all, and have a great day.